14.3.1 effects of the refraction of the light. We are here now. So, when we are looking at a swimming pool, with, with an angle uh, as a point of view, as an example, like uh, imagine now you are here, right? Now this is the pool. You are here, right? Now we have the water here. And this is the bottom of the pool, right? When you are looking at the pool, you will see that the bottom of the pool is not not much deeper than you think, because right now it's a magic, because the bottom comes up. When you see, when you're looking at the bottom from this place, bottom will come up, right? මේ මේ bottom එක උඩට ඇවිල්ලා වගේ තියෙන්නේ, right? Then you will feel this is not deeper than uh, 2 or 3 feet, and but it is mentioning the deep end is deeper than 5 feet. Actually, it is 5.5 or 6 feet. But you feel it like it's only deeper. The depth is that means the apparent depth. Apparent depth is only 3 feet. Right? The actual depth, the real depth is here. It is mentioned on the wall of the pool as 6 feet. What's happening here? The the bottom, the the bottom has come, right? මේ bottom එක ඇවිල්ලා තියෙනවා. කොහෙටද? උඩට. එහෙම වෙන්නේ කොහොමද? right? මේ විදිහටම ඔයාලට දකින්න පුළුවන් ළමයි. මොකක් හරි වාජනයකට කාසියක් දාලා උඩ ඉඳන් බැලුවා. කොහොම බැලුවා මේ කාසිය උඩට ඇවිල්ලා වගේ පේනවා. උඩින් බැලුවා. right? මොකද්ද මෙතන වෙන්නේ? හරි. pool එකක මෙහෙම පේනවා. ඒකයි අර ළමයි දැකලා තියෙනවද? දැන් අපි pool එකකට වෙලා ඉදි උඩ ඉඳන් ෆොටෝ එකක් ගත්තොත් අර නිකන් අපේ කකුල් නිකන් උඩ තියනවා වගේ පේන්නේ. අපි අර කොටට වගේ පේන්නේ දැකලා තියෙනවා. කවුද එහෙම දැකලා තියෙන්නේ? නෝට් කරලා තියෙනවද ඒක? यहाँ सा कितने लिए सन
Yes, sir.
right ඒ වෙන්නේ මෙන්න මේ effect එකේ හින්දා refraction වල it is happening because of the effect of this refraction that means you can experience the difference between the real depth that means the actual depth and the depth that you feel that means the apparent depth right the depth that the apparent depth is the depth that your brain understand as the depth. It is not the real depth. So our brain is tricked by the light. Our brain and our eyes and our mind is tricked by the eyes by hiding the real depth. Right? Right. මෙතනදි වෙන්නේ මොකක්ද? ඔන්න දැන් බීක එක තියෙනවා. වතුර පුරවලා තියෙනවා. හරි. මෙතන තියෙන ඇණයක්. නමුත් මේ ඇණේ පේන්නේ උඩට ඉස්සිලා. apparent depth එක තියෙනවා. real depth එක මේ භාජනයේ තියෙන වතුර පුරවපු උස. But the apparent depth is here, only this side. Right? It is clear that the observable depth or the apparent depth when views from top is always less than the real depth. It is always less. Right? It's a magic. It is important to think carefully before the step down into a well or a reservoir because of the real depth is of it is more than the apparent depth. අපිට ගැඹුරු නෑ වගේ පෙවුනට ගැඹුරු. හරි. මෙතනදි වෙන්නේ මොකද්ද ඇත්තටම? හරි. මෙතනදි වෙන්නේ මොකද්ද කියන එක මම වෙන්නන්න මට තප්පරයක් දෙන්න. රයිට් ළමයි. මේ ගැන ඔයාලට හොඳටම ඉගෙන ගන්න හම්බෙන්නේ ගණන් හදන්න හම්බ වෙනවා A level වලදී. රයිට්. එක දිගට ගණන් හදන්න හම්බ වෙනවා A level වලදී. ඒ හින්දා කිසි දෙයකට බය වෙන්න එපා අඩුවක් වෙන්නේ නැහැ. හරි. ඒ කාලෙට එපා වෙනකන් තියනවා හදන්න. රයිට්. ඔන්න කියලා දෙන්න යන්නේ පොඩි කියන්නේ ඔයාලගේ සිලබස් එකෙන් එහා කැරලා. Right? Now you can see my screen. Right. Now here is right. Here you have a pin at the point of O. Right? Now you are looking at it from here. Right? Actually, these two rays are coming to the eye. Hari? හරිද? දැන් ඔන්න මෙතනගෙන එක රේ එක ලයිට් රේ එකක් කෙලින්ම එනවා. නේද ළමයි? මට මුලින්ම කියන්න මේක ඉස්කෝලේදී කියලා දුන්නද? වෙන්නේ මොකද්ද කියන එක? හරි. O point එක තියනවානේ මෙතන. right. O point එකේ එක light ray එකක් එනවා උඩට තනි කෙලි. right. It is parallel to the normal line. So it will not bend away or towards the uh, it will not make a bend, right? So it goes directly without being bending, right? Then the other ray is coming with an angle to the eye, and it meets the normal line at the interface. Then the light ray is coming from high dense medium to less dense medium. So it will bend away from the normal line. Clear? Clear the lamai? ඔහොම ඇවිල්ලා පොඩ්ඩක් හැරිලා යනවා. right මේක ඇත්තටම ඔතන ඇඳලා තියෙන එක වැරදි. ඔయిత වඩා හැරෙනවා. right ඔය ගානට වගේ හැරෙනවා. හරි. ඔයාලා මේක අමතක කරන්න. වෙබ්සයිට් එකටත් වැරදිලා. ඕක අමතක කරන්න. හරි. හරි. right then you feel it like the light ray is coming from this point, not from more, because when we extend this arrow to back, it is coming from I. So your brain will understand that this light ray is coming from I here, because this direct ray and this refracted ray is meeting at the eye. They are crossing each other at the eye. So your brain will be tricked by the light by taking this object into the position of I only because of this ray, this refracted ray, because that refracted ray is extended back, and it will meet the direct ray in the point of I. So this O is now in I. Is it clear now? This is the magic. Clear the mega. Kitnuli, Sanumi.
Clear, sir.
This is what happens as the effect of refraction. Then Then now this is the real depth, right? And this is the apparent depth. So the apparent depth is not real. Huh? You have this gap, then it has the risk because our brain is tricked. We have to understand before walk into a pond or a pool or a reservoir. We have to get the real measure of the depth of that pool, right? Right. So this is what happens to the birds, like uh, actually to the all the birds, not only for the kingfishers, right? Now they are seeing, now they are looking, they are observing a fish which is swimming in a reservoir. But actually they see the apparent depth and the fish is swimming near to the surface, not in this depth. But this fish has the idea by the evolution to understand the real depth. So it can catch the fish without a problem. Because මෙයා දන්නවලා බයි මෙයාව මෙතනින් පීනනවා වගේ පෙවුනට මෙයා ඉන්නේ ඊට වඩා යටින් කියලා. මෙයා ගානට යන්නේ ඇත්ත ඩෙප්ත් එකට. එයාට ඒක ඇවිල්ලා තියෙන්නේ ඉවොලුෂන්. එයා ඒ අවබෝධය අරගෙන තියෙන්නේ ඉවොලුෂන් එකෙන්. රයිට්? මෙයා දන්නවා. මෙයාට අමුතුවෙන් උගන්වන්න දෙයක් නෑ. ඇත්ත ඩෙප්ත් එක මොකක්ද කියන එක. රයිට්? මේ දෙයම වෙනවා අර නිකන් පැන්සල කැඩිලා වගේ පේන්නේ. රයිට්? පැන්සල කැඩිලා වගේ පේන්නේ. එතරම්දි වෙන්නේ මොකක්ද? හරි. එතනදි වෙන දෙයක් පැන. This is what happened when you are when you are looking at a pencil which is right now. I think this is okay. A better one, like here. I think you can see the image. कितने सानुवी सेंसा. Is it clear?
Yes, sir.
Right. All these things will be included at the note, huh? So don't.
Yes, sir.
Right. All those things will be included at the note. Nothing to be worried. Right. Now you have to just understand and I will give the note. Right. Now think about this A. not A dash. This is A dash. This is A, right? Now two light rays are, are coming from A to the I. Here is the I. And at the interface, those two light rays will be bent away from the normal line, right? It will be bent away from the normal line. Ne? And you will see these light rays are coming from this A dash, because if you extend the light rays which are grabbed by the eye, it will meet, those light rays will meet at this A dash. So you will find this, that the tip of the pencil, pencil tuda, the tip of the pencil is in A dash now, right? So this will happen all along the pencil, which is the part of the pencil which is sinking, right? Now we are talking about on, only about this point, right? A. Now the same thing is happening from this point, 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 this point. So you will see a complete broken pencil, and the tip of the pencil will be in A dash, right? Because when you are extending the light rays back, the tip of the pencil will be at A dash. So you will see a nice broken pencil, right? Is it clear, Lamai? The same light rays, the same thing will be happen in other points. Like if I draw it, right? If you are considering this point, right? I will draw some rays, right? From this point, one light ray will be will behave like this, and other one will behave like this, right? So when you are extending, I will draw it in green. When you are extending the line back, it will meet here, in here, right? So this red point will be appeared as with its apparent depth, where in here, right? This is the same thing which was happened to the A dash. I think this is clear, Lamai.
Clear.
Hmm. Right. දැන් අපි යමු ඊළඟ කොටස. Right. Refraction of light through a prism. Prism making when a refraction එක. A wonderful occurrence will be observed when light passes through a glass prism. Right? Light එක වීදුරු ප්‍රිස්මයකින් වීදුරු ප්‍රිස්ම එකකින් පාස් වෙලා යද්දි මොකද වෙන්නේ? මෙන්න මේකයි වෙන්නේ. First, we have to understand this scenario. We have to draw only a normal line which is perpendicular to the interface. Right? Now, you have the incident ray at black and the refracted ray with 7 colors inside the glass, and you will find this ray is bent towards the normal line, because if it goes through the glass prism without a refraction, it will behave like this. It has to go like this, right? But it has refracted without going directly, right? And that white light ray has divided into the 7 colors. රන්තැමිලි කඩන කොල්ලෝ නිල්ලිබ්බෝ දකිති. Roy GB4. Red, O, orange, Y, yellow, green, GB, blue, 4, I, indica, violet. Indigo, violet. Right? මේ පාට හතට වෙන් වෙලා යනවා. This is called the spectrum of 7 colors of the light. This is the spectrum of 7 colors. Can be seen on the screen during the activity. Because after getting separated in the interface of the glass prism, those 7 colors will travel through the glass prism, and then it meets 7 points of interface to be released to the air again. So we have to draw 7 normal lines now. Then you will understand the path. One normal line will not help to understand. Now, this is not the purpose of exams. This is for the purpose of understanding about your experience of using prism. Right? Here, if I am drawing much more normal lines, it will be not clear. So I am stepping from 5. Right? I will stop from drawing to the red, and to the blue. This is what happened. Right? This blue color, wait, this has to be like this. Right. Now, this red color has bent away from the normal line. නේද ළමයි?
Yes, sir.
And the blue color is also has bent away from the normal line. Now you have you have to draw two normal lines. One from the other surface and the one from this surface to understand the whole scenario. This is what happened to the blue, indigo, yellow, all those things are bent away from the normal line. Then you will find the 7 colors of spectrum due to this separation of light. This separation of light is happening because of the lambda. Lambda means you will learn it in the future. That means the wavelength of the light, right? It is only because of the wavelength that the lambda is the symbol of the wavelength. So you will study them in the future, right? Now that if I am explaining what is happening here, I have to use the term the wavelengths, but you will not understand. So I am not going to explain it. I will touch the textbook. It is the limit, right? The separation of the white light into 7 colors when passing through a prism due to the refraction, right? It is due to the refraction. But why this is separating without passing, not being separated into 7 colors is not explained, right? Due to the refraction is the reason for this. It is enough. Colors of the spectrum are red, orange, yellow, right? Separation of light when passing through a prism is known as dispersion. The term is dispersion, right? Now, you have to remember the white light is made of 7 colors, right? You know that. The white light is made of 7 colors. And with the dispersion, it will be separated by the glass prism into its components, right? White light has always 7 components. All those together, we will see it as it in white, but it is not white actually. It has 7 colors, but our brain is again tricked. It has as white, right? But it is not white. It has all 7 colors, right? So it is called the separation of white light when passing through a prism. Separation of white light when passing through a prism. Prism is known as dispersion. Right, ළමයි? So, මේක පුංචි කාලේ කරලා ඇති පාට 7 ගාලා. හරි. මේක අයිසැක් නිව්ටන්ගේ වැඩක්. ඒ කාලේ කරපු වැඩක්. හරි. Isaac Newton shows that the white light is composed of 7 colors. මේකෙන් තමයි පෙන්නන්නේ. So Isaac Newton කරපු තව දෙයක් කියන්න බලන්න. සනුමි right අද ගෙදර වැඩේ අයිසැක් නිව්ටන් හොයාගත්ත ප්‍රධානම දේ group එකට දාන්න ඕන. group එකට නෙමෙයි මට private message එකක් විදිහට තුන්දෙනා වෙන වෙනම දාන්න ඕනේ අයිසැක් නිව්ටන් සර් අයිසැක් නිව්ටන් මොනවද ලෝකෙට කරේ කියන එක දෙයක්. right you have to send it as a private message about the role about the main role main finding of the Sir Isaac Newton except this white light thing, right? The equipment he has used this as known as Newton disk. Newton disk කියලා කියනවා මේකට. Newton disk is made by painting the segments equally divided through the center of a circle of 7 colors, right? When this is painted, circle is rotated the 7 colors to mix give the white color. මේක වේගෙන් කරකවුවාම අපිට පේන්නේ සුදු පාටයි. right? මේකට කියනවා Newton's disk කියලා. right? right. Occurrence of rainbow. So the occurrence of rainbow is happening because it's very similar to the dispersion which can be experienced through a glass prism. Right? Rainbow is another elegant phenomenon that occurs due to reflection of light. Right? So in here, that water drop or a raindrop is now in this word rainbow, we have the rain and the bow. Bow is dunna, rain is rain vessel. Right? Now, when you are separating these things, you will find there's something which is related to the water is there. It is rain. So, when the light is passing through a raindrop, right, it will be divided. That white light will be divided due to refraction to its 7 colors. Right? And inside the rainbow, the difference between the refraction which is happening in the glass prism and the which is happening in the within the rain droplet, the difference is the inside the rain droplet, the light is bouncing back at a one place. So it is reflection. So in here you can find both refraction and the reflection. Theories. Right in here. First, the incidence ray is coming towards the rainbow. The incident ray is coming towards the rainbow. And it is directly coming, and it will not be reflected because it is perpendicular to the interface, and it will කඩාගෙන යනවා මේ වතුර බිඳුව, right? But at this point, if we have to draw a normal line to understand this, right? The light ray is reflecting again. It means bouncing back again into the raindrop without going away from the raindrop, it will bouncing back, right? Then, so now you are thinking like, ඇයි ඒක bouncing back වෙන්නේ? ඇයි එළියට යන්නේ නැත්තේ? Right. It is due to this angle. I will explain it because your textbook is not explaining anything that they are expecting you will wait until you are reaching to the grade 11 or grade 13 or 12. But I know you are anticipating these things to be learned, right? Now, here, the light rays bouncing back, and what will happen here? To understand what is happening here, we have to draw another normal line. Right. Now, the light ray is coming, and they're reflecting in this point, and it meets this interface, and it will be refracted again. So now, when it is cloudy, wet climate with high humidity, the environment is, you can find those tiny raindrops within the air, right? And the light will be reflected and the refracted within those tiny raindrops. Now, why it is not refracted here, right? ළමයි මේකයි වෙන්නේ. මෙන්න මේ පොයින්ට් එක ඔයාලට වහලා තියෙනවා අචුපතු. හරි. අපි මෙහෙම ඉන්ටර්ෆේස් එකක් ඇඳ කියනවා. ඊට පස්සේ මෙහෙම අපි normal line එකකුත් අඳිනවා. හරි. දැන් ඔන්න now I am drawing a incident ray which meets the interface. Wait. I will use the color. Which will meet the interface in this angle, right? And now this is water. Here this is water. Wait. Right. Here this is water. I will write in W, and this is air. I will write the A. So this incident ray is coming and meet the interface here, and it will bend away from the normal line, right? Then I will draw another one. Another incident ray is coming, and it will draw that new incident ray is coming, meeting the interface in a higher angle than the first one, and it will bend with a higher angle, right? Again, another incident ray is coming with a higher angle than the previous one, then it will bend with a higher angle. Now I will number this, so otherwise you will පටලවා ගනි මේක. හරිද? අනිවාර්යෙන් frame පැටලෙනවා. Now this is the one, this is 2, this is 3, and here this is the 1, this is 2, this is 3, right? Then another one, right? I will draw it in gray, right? Will meet the interface in this angle, it is much higher than the first one. And the light ray දැන් ළමයි light ray refractor ray එක මෙහෙම නැමිලා දැන් යන්නේ. angle එක තව වැඩි වුණොත් වෙන්නේ මොකද්ද? මේ interface එක දිගේ යනවා. එක ray එක. clear? මෙහෙන් මෙහාට යන තරමට අර එහෙන් එහාට යනවා. මෙහෙන් මෙහාට යන තරමට මෙහෙන් මෙහාට යනවා. clearද?
Clear, sir.
Right. Now what will happen if we increase the angle of incident again? What will happen? I will draw it in blue. What will happen if we are going to increase the angle of incident again? This will bounce back to the same medium. This is what happened. This will bounce back to the same medium. This is what happened here. Clear the Hituli. Clear the
Yes, sir.
right. එතකොට වෙන්නේ මේකයි. මෙතරින් මෙහාට යන තරමට මෙතරින් මෙහාට යනවා. එක මොහොතක් එනවා. එයා ආපහු ඒ මීඩියම් එකටම ඇතුල් වෙන්නේ. ඒක තමයි මෙතනදි වෙන්නේ. right? සනුමිදුව ඩිස්කනෙක්ට් වුණා නේද? ආයි කියනවා. මෙහෙම ඇවිල්ලා ඔන්න කොළ පාට ලයින් එක එනවා. එයා යනවා සර්ෆේස් එක දිගේ. right? Then now we try to increase the angle of incident. Then at a one point the incident ray will bounce back to the same medium. Right? It is drawn here in blue. And this is what happened at this point of the raindrop. When you are increasing the light angle of incident continuously, at a one point you will find this green line and the incident ray is green and the refracted ray will go through the interface. Then you will continue the increasing of the angle of incident. Then this right ray will bounce back to the same medium, which is water. Right? And this is what happened within the raindrop and in this point. Right? I think it is almost cleared. Right now. Then we have to move to the simple meshes. I will stop